Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today's discussion is part 8 of an ongoing series focused on Configuration Manager Current Branch and the Microsoft Cloud, Azure. Today's session will focus specifically on imaging and provisioning in Azure. Really want to take a look at imaging and provisioning and show what it means in Azure and how it's possible to extend typical on-prem types of imaging to Azure. Also note, what I will show in this session really is in line to illustrate what's possible. The approaches may or may not be suitable to your needs, but are great examples of the flexibility of Azure to allow common on-prem practices to extend and be leveraged in Azure as well. So the agenda for our discussion, going over what really is imaging and provisioning in Azure. What do we mean when we say that? Why we care about the discussion of imaging and provisioning in Azure. Just want to spend some time introducing some concepts and terminology. This is kind of more along the lines of setting the stage by explaining some concepts and different things that are in Azure, not an Azure 101 full discussion kind of thing, but especially for those who haven't really spent much time in Azure, it would be helpful to understand some of these things before you see them. And then we'll spend the bulk of our time in the whole discussion around imaging and provisioning in Azure, specifically what the options are, how it works, right? And then to actually see it in action, we'll wrap up the session with a few tips and tricks. So let me say at the outset that what we're going to be doing in this session is really just an example of the kinds of things that you could do in Azure as you think about provisioning, as you think about imaging. While I'm going to give you some, I think, good examples, definitely not an exhaustive set of things that you might do, right? Because imaging, at the end of the day, really does depend on the specific needs of an environment and how we can implement those. And, like imaging itself on-prem with OSD and some of our imaging tools, being flexible, so can you have some of that same kind of flexibility and inventiveness whenever we think about bringing certain approaches to Azure, right? All right, enough about that. So what is provisioning, imaging in Azure? Well, put simply, it's what you would expect. It's the process to build systems in Azure, virtual machines for production deployment, right? Sometimes the question is, is there a difference between on-prem versus Azure? And certainly there are some differences that we will need to think through. But at the end of the day, Azure is just an extension to your data center, just like another physical data center that you own would be an extension to your data center, right? And so some of the same kind of practices that you would leverage in your data center, you could also leverage in Azure, right? When we think about imaging and provisioning, there's really two big categories. For provisioning, we think about templates. And in Azure, templates are very similar to the process that we've known for years about using templates to provision VMs in Hyper-V or VMware, right? Basically, you apply the template, you will customize after applying the template using various tools, and that's one way of getting new systems built and ready to go. Imaging, frankly, is imaging. Like we've known it for years, using the tools that are very familiar, the Windows ADK, through and doing manual imaging, perhaps using a lot of the tools that are in there that you'll see in a minute, the ImageX, the DISM, the disk part utilities and different things, right? We can do a lot with manual imaging, right? But then we have MDT, we have OSD, which take those tools, bring automation to those tools, and make it an easier, more seamless experience than trying to set up everything from scratch and do it manually, right? So why do we care about this whole discussion about imaging and provisioning in Azure? Well, for a few reasons, right? Azure, again, extends your data center. In your own data centers, whenever you build machines, especially with OSD and MDT or so on, there are corporate standards that you have to plan for whenever you produce these machines and hand them off to be used in your production environment. The same kind of idea could be brought to bear in Azure, right? And it just is a matter of understanding how Azure works and the tool sets that are available to see how we could apply those things, right? So, and also, again, kind of the same thing, apply corporate standards and being able to enable required on-prem processes, but make it happen in Azure. So some concepts and terminology just to get started in the discussion that I want to call out. There's general terminology, and then there's Azure specific terminology. So let's start on the general side. And these terms should be familiar to anyone who's done much with imaging. So I'll go through them fairly quick, right? So there's the Windows ADK. This is basically a set of tools that support the imaging of Windows systems. Lots of tools within the ADK, as you'll see in the list below. Windows PE, part of the Windows ADK. Windows PE, a lightweight version of Windows used for deployment of systems and troubleshooting. It's unique in that it runs from memory when the system, that's going to be important. When the system boots, Windows PE will run from memory. It may start off on media, such as an ISO boot media, USB boot media, or what you'll see in a little bit is kind of some inventive ways that I'm going to show you. You can make it work off of a hard disk, right? When it boots, it will come off of the hard disk and into memory, which makes it very unique, because even though then the C drive was used to boot, now since it's in memory, you can manipulate the C drive, no problem. I'll probably say that a couple of times, right? Windows PE is an environment that provides some default settings, but you can add additional components to customize it as needed to support the specific needs of your environment, right? DiskPart is a tool to help you manage the configuration of disks. That includes partitioning, formatting, mounting the disk, etc., right? BCD boot, a tool used to help create or repair your boot image files, right? So if you want to create a bootable partition, BCD boot will help you do that and make it easy. ImageX, a tool that supports the capturing, modifying, applying of your image files, the traditional WIM format, right? There's a tool called WinPE init. Now this is a command line tool that will initialize Windows PE at boot time. There's the VHD. Now this one's interesting because when we think about virtual machine disks, right? Today in the Hyper-V world, we think about VHDX format. Azure doesn't support VHDX. Azure only supports VHD. So whenever we're thinking about building virtual disks to be used in an Azure environment, we have to be factoring in VHD, right? And there's probably another few terms we could throw out here on the general side, but that's enough for this, right? On the Azure specific side, want to start with just kind of a couple of different ways we think about provisioning or deploying in an Azure environment. First, there's classic deployment, right? Then there's resource manager deployment. And you'll see throughout the Azure console, whenever you build new items, you'll have a choice. Use the classic model, use the resource manager model. So what are these things? So the classic deployment model was the first and only deployment model whenever Azure was first introduced. So it uses a unique set of APIs to interact with deployments created in the classic model. It is not compatible with any other resources deployed using the resource manager deployment model, for example, right? The resource manager deployment model, so you see I have an asterisk there. The reason I do is because this is something that was, something that was added in 2014 as a new deployment model. It is actually the one that we recommend now for all of our current and future deployments. Like the classic deployment model, it is not compatible with resources deployed using the classic deployment model. It also has its own set of unique APIs. Again, we recommend this for all new deployment of resources. And also, we recommend that if you are using the classic deployment model, that you actually will redeploy your resources using the new resource manager approach. Why? Well, there's some pretty clear benefits of using the resource manager model. I blew those out to the right-hand side. You can deploy, manage, and monitor all of your services as a unit. So as we get a little bit further, I'll show you a graphic. You may see some things that will help solidify this in your mind. Resources in Azure often include various different things that work together to make the overall service happen. So it could include a virtual machine, and then it could include virtual networks, and then it could include websites, and then it could include a database, right? SQL database, whatever, right? So all of these things might need to be treated together and monitored together as a single part of the service. So the resource manager deployment model really helps you do that. The resource manager deployment model will help you repeatedly deploy the given solution throughout its lifecycle and make sure it remains in a consistent state. You can put access controls here. You can apply tags. You can use JSON and define dependencies, and on we go, right? So resource manager deployment is seen to be the preferred model these days. All right. So whether you choose resource manager deployment, whether you choose classic deployment, you have other things that you will get involved with, such as resource groups, right? So resource groups, really important item, because in Azure, resource groups are basically the main container that will contain resources that share a common lifecycle, right? So if you do have a deployment where you need, all these different pieces together, SQL, website, VM, whatever, it might make sense to put them all within a single resource group so you can act on them together, right? Storage accounts. So in Azure, we do have a need to store data. Well, the way that you store that data will be in a storage account. A storage account has 4 different flavors, if you will, right? There's file storage. That's familiar. File storage basically provides shares that can be managed through Windows Explorer, right? You can use the familiar netuse command to map a drive locally to a storage account that is sitting in Azure and access data from there, right? You can use netuse for virtual machines sitting in Azure to connect to storage accounts and so on, right? File storage is probably the most familiar to what we see today with disks and so on. Then there's blob storage. So blob storage stores specifically unstructured data and objects. Examples of that would be text or binary data, documents, media files, application installers. This is the specific type of storage that is required for hosting virtual disks that are used by virtual machines, which in our discussion today, that's VHDs, right? So those are the 2 types of storage you'll see me use in just a little bit in the demos, right? Beyond those 2, there's table storage. So this is the kind of storage used for NoSQL, structured data sets and so on. Then there's queue storage, which is unique to messaging and communication between cloud services. You won't see me use those today. Then we have the concept of virtual networks, where that will enable Azure resources to communicate with each other, the internet. It helps you isolate your given resources that are running in Azure from other resources that are running in organizations beyond yours that are also hosted in Azure. Virtual networks can be connected to each other as needed to make up whatever networking structure makes sense for your business. And then finally, virtual machines, very familiar, just like any other virtual machine running and communicating in Azure, can be connected to your on-prem environment, etc. Right? Okay, so graphically, it's kind of cobbled this together to give you an idea of what I'm talking about. We have Azure, this big cloud service. In Azure, you will create 1 or more resource groups. The resource groups are basically the sandbox that contain other objects. So on the left, I have resource group 1. And in resource group 1, I have a few things. I have some IP addresses that might be assigned, some virtual NIC details that might be assigned. Those are specifically located in the resource group. They are not part of the storage account in resource group 1. The storage account itself is also a resource in resource group 1. This particular storage account, blob storage, will include files, for example, whims that you're going to be using through the environment to actually apply images to systems and so on, right? So that might exist in resource group 1. Resource group 2 will maybe contain other resources. So resource group 2 will have its own storage account. Here might be where you put VHD files, upload your VHD files, your images that get created. There might be virtual networks and virtual machines that are created over here. And the interesting thing, resource groups can also talk back and forth. What you'll see in my lab shortly is that I have a couple of different resource groups that I'm using for imaging. They are able to see each other and communicate with each other, right, without a problem. It's just resource groups are unique groupings that might make sense for a given scenario, right? All right. So this concepts and terminology stuff, let me show you real quick an example of just a couple of things, resource groups and then also storage accounts. Let me pull in my Azure environment. So if I go to resource groups first, right? So I have a few. These are the two that I'm going to be using in my demo today. There's others that are created through here, right? But if I use my Azure imaging group and just click on it, then it will take me to some detail. And this first overview section will show me specifically what is contained in my given resource group. So in my given resource group, you see I have 2 images, just a standard WinPE image, a second WinPE boot image. These are components of the lab that I'll show you in just a minute. Then I have my storage account, Azure Imaging Storage Account 1. So if I click on the storage account, you'll see that there are the 4 items, 4 types of storage. I have my blob storage, my file storage, my table storage, my queue storage. If I go into each one, I will be able to see what is contained in my storage account. So in my POC VHD, I have my 2 VHD files that I've uploaded. These are my virtual disks that I will be leveraging in demos, right? Well, let's scroll all the way back to the left and let's pick our other storage account or resource group here. Okay. So here I also have a few things. I have my virtual NICs, my virtual IP addresses. I have my virtual machines, right? And then I have another virtual machine, my storage account. So right away, you can see my virtual machines are actually in this resource group, but my virtual disks are in the first resource group. So right away, in order for those virtual machines to work, I can cross boundaries between resource groups. Let's look inside our storage account that's unique to this resource group. So in the storage account, same kind of deal, blobs, files, whatever. If I look under blob storage, you'll see these are some diagnostic files. These aren't specifically related to the VHDs that I would upload. This enables some things that I'll show you in a minute, some boot diagnostics. That portion of the virtual machine, which is really important to help us see what's going on in the Azure environment, is enabled by having the files here, right? Let's scroll back to the left. Let's go to the files section. So under the files section, don't have anything in this one. I thought I did anyway. I must be forgetting where I put the files, but anyway, you get the idea, right? How some of this, kind of fits together. So let me go ahead and pull this back out of the window. All right. So imaging and provisioning in Azure, a few options. In terms of the ways that we can actually do imaging and provisioning in Azure, few things to call out. So Azure templates, I'll show those to you in a minute. Again, this is very similar to the kind of ways that we would do things in Hyper-V or VMware, right? These are generic builds, essentially, that will get loaded into machines. And then once those generic builds are loaded, you can further customize them to the needs of your environment. You can use things like PowerShell DSC, Chef, or Puppet. You can even, if you load the ConfigMgr client on the box and you don't have, it's not time critical, right? You can wait for policy to check in and so on. We can deploy task sequences that are non-imaging task sequences that will help you customize post-build, right? As an example. One thing to think about here as we go through this, I don't want to forget to say this, so a little quick tangent. As we're thinking about using Azure, and especially as we're kind of talking about next Windows PE, right? One of the things about building in Azure is while you're in the Windows PE mode, as I'm going to show you in a minute, you will not have console access to the system, meaning you won't be able to RDP to the system. So while in an on-prem environment, even with virtual machines, we're accustomed maybe to being able to connect to that virtual machine, interact with the PE build process and so on, you won't be able to do that in the Azure environment. So it's very, very important that you build everything in a way that is automated. So what does that mean? That means if you're using just standard PE, if you're using boot media, that everything that is required for the deployment be made available and be made to kick off as soon as that system boots, because you won't have any interaction. In the config manager world, that means required deployments. That means using variables. I'll probably say that again, right? So anyway, just wanted to mention that. So specifically turning away from Azure templates and thinking about other options, right? We have Windows PE in Azure. So this would be kind of using the tools in the Windows ADK to do manual deployment, right? Again, just to say it again, what is OSD? OSD at the end of the day is basically a really nice tool set to automate a lot of what you could do manually if you needed to, with Windows PE and the ADK tools, right? So one of my colleagues, John Saville, put together a really, really good blog that details how to do this, right? And that's the blog that I'm going to use to demonstrate how John did it, frankly. And John and I have talked back and forth about it, and really kind of a slick approach to not only show how to use PE in Azure, but just some of the ways that will make your life easier in terms of PowerShell scripts and so on that I'll show you in a minute. So if you want to use Windows PE by itself, great example of how to do that. I'll show you that in a minute, illustrate some concepts. ConfigMgr OSD in Azure, at the end of the day, basically uses a ConfigMgr customized Windows PE. So we have a number of different options we might think about whenever we consider ConfigMgr. That would include boot media or standalone media. There's also a build to VHD option that historically has been available in the console, right? So already you can tell that those top three just are not going to be workable in an Azure environment. Why? Boot media, a couple of reasons, right? Well, first of all, boot media, you might think of Pixie, right? Pixie is basically a way to deliver a boot media type experience. Well, Pixie is not supported in Azure, right? Also, there's no VM console access in Azure where you can mount either a USB stick or an ISO file. So the next thing you would think of is, well, okay, great. Let's take boot media and convert it to run from a hard drive, your VHD itself. And that's not supported either, right? So boot media is really not an option, but let me put an asterisk there, right? Standalone media, for the same reasons, not an option, right? Because we really don't support running standalone media from the hard drive. It's intended to run from USB or ISO file, and same challenges there, right? Put an asterisk there too. Build to VHD. Now this one would be interesting because you could actually use build to VHD to create your VHDs. The intention of build to VHD was to do that exact thing and then stage those VHDs in Virtual Machine Manager. Well, as of ConfigMgr 17.10, we have deprecated that feature, so it's no longer even available in the console. So now it's not an option either at 17.10 going forward, right? So that leaves us with this idea of pre-stage media. So with pre-stage media, completely works in an Azure environment. Why? Because pre-stage media, when we apply the pre-stage media task sequence, what it will do is drop down some different configuration files and so on, ultimately creates a bootable hard disk, right? Well, so I put some asterisks around boot media and standalone media because they aren't supported booting from hard disk. But if we take a bit of an inventive approach to pre-stage media, we can actually create the equivalent of a boot disk, boot media disk or standalone media disk, but in this case have it running from the local hard disk. So I'm going to demonstrate that method in a minute. Fully supported way to do it using this pre-stage media approach. So beyond those three ways, are there other ways to build and do imaging in an Azure environment? The answer, yeah, very possibly, right? It really depends on your specific scenario. Just like the way you implement OSD and the things that you do in OSD really depends on your specific environment needs. Same thing here, right? There may be ways that I'm not going to show you, or modifications even to ways that I am going to show you that would be more appropriate for your environment. That's great, right? As long as we can think through those and those work, that's awesome, right? One other piece I'll throw in here. So in an Azure virtual machine environment, you won't have traditional console access, right? Like we think of with Hyper-V or VMware. But that doesn't mean you don't have some options. So there's a kind of a console-like, console-type experience that you can get by using our instance metadata service. So there's a link here for you to go look at that if it's of interest, right? It doesn't have all the things that you would expect maybe in a console experience, but it does allow you to interact at a level more similar to a console type access. So I'll leave that part there. Okay, so imaging provisioning specifically in Azure, how does that work? Azure templates, right? First thing we'll talk about is Azure templates. And actually, I'm going to save the discussion of Azure templates to the demo part. The process is just very similar to what you would do with Hyper-V and VMware templates, but I'll save that discussion for just a minute and come back to it. Okay, so let's switch gears. So how does it work for Windows PE in an Azure environment? So this I'll spend a bit more time on just to kind of give you the flow, then I'll show it to you live, that kind of thing. So if we're going to be leveraging Windows PE in an Azure environment, a few things we need to do. First, we need to create the Windows PE source if you don't have it already, because the Windows PE source is something we're going to manipulate, add a couple of things to, and then basically put onto VHD and put into the Azure environment. So we need that source to start with. Once we have the source, then we want to mount the WIM specifically from the PE source, and we're going to modify that WIM again to add some pieces if we want to, need to, that we will then use going forward. So we'll mount that. Once we have the WIM modified, we're going to create a test VHD, right? And at that point, we've basically taken Windows PE that we created here, modified here, and we're dropping Windows PE onto the test VHD so that whenever we boot from that VHD, Windows PE comes up. Then, once we're in Windows PE and running, we're going to apply a WIM that will be the operating system that we're ultimately wanting to image onto the disk, right? So we'll do all of that in our on-prem Hyper-V environment in my case, right? Why? Because testing this is absolutely critical before you, locally, before you try to translate it to Azure. In Azure, you don't have controls when Windows PE is running to do a lot of manipulation and testing. You basically have visualization into what's going on through some things I'll show you, boot diagnostics and so on, but you don't have any hands-on. So making sure it works locally is really important. Then you can adjust the VHD for use in Azure and then stage both the new VHD now configured for Azure and also the WIM that you will use to image onto that VHD in Azure. Let me be clear about one thing. Hopefully it's clear already, but if not. So I mentioned WIM a couple of times. Here's an instance of where I mentioned WIM, right? In that case, the WIM that we're mounting and modifying is coming directly from the Windows PE source, right? It's there as a part of when PE boots, it will load the WIM down onto the drive, and that's what will be the running operating system, right? That's separate and apart from this WIM, which would be the specific operating system you're wanting to deploy onto the VHD. So think of it this way. WIM number 1 facilitates the boot of PE and creation of PE on the RAM drive, right? WIM number 2 is going to lay down onto the VHD after PE is booted and basically replace what was on that VHD, so the next time it boots, it will be the new image, right? Anyway, so once we have all that done, we'll have to stage, again, the WIM that we're going to use for imaging and the VHD with PE loaded up into Azure, and then hook it all up with NICs and IP addresses and so on, attaching it to the virtual machine that we are going to create in Azure so that we can turn on the virtual machine, boots from the VHD we've configured, and the imaging process takes place. Right? So I'll show you all of that. Now, there's some specific commands to make these things work, and I'll show them to you quickly here, but I'll also show them to you live. So first, we have to create the Windows PE source. We do that with a command, as you see on your screen, copy PE, right? Now, these commands, a lot of them will come from the Windows ADK version of the command prompt, the deployment tools command prompt, essentially, which I'll show you in a minute. Whenever we go to mount and modify the WIM from our PE source, we'll use a series of commands. DISM will both mount and dismount our image. So the mount will allow us to modify the image. The dismount will take the modifications and basically commit them so that they're part of the WIM. And then along the way, if we need to add additional components, packages in the DISM world to the image, we can do that with the DISM command. You see one example up here, the add package. In John Saville's blog, there's a lot more examples of different things that you can add, but for brevity, I'm just going to use these few. And then finally, I'm going to be copying in my a copy of ImageX that will be important for deploying the image and so on. All right, and then after that, we're going to create the test VHD. Now, I can do that a couple of ways. I could use disk management, or I can just go and use disk part directly. But essentially what I'm going to do is create my virtual disk. You see the name of it here, provision it, partition it, assign the drive letter, and then exit. Once I exit, I'm going to basically move my Windows PE configuration onto the VHD. There's a command for that as a part of the Windows ADK. Make Win PE media. Just going to copy it over. Once I have it copied over to the VHD, that VHD is ready. It is Windows PE bootable. And whenever I'm done with that, I'm just going to detach the virtual hard disk. I have to go back into disk part to be able to do that. All right, with all that done, then I need to prepare the WIM, or prepare Windows PE so I can apply the prepared WIM. Well, there's a couple of ways I'll do that. So creating PE is part of the battle. The second part is engineering PE so that whenever it first boots, it will proceed with the process of applying the WIM. Well, how do we do that? Well, we need to create, first of all, a disk part script. So once PE boots, the control is off of the local hard drive. It's in the RAM disk. So now we can run through a disk part script to prepare that local C drive for imaging, right? And this script basically will take the C drive and clean it and partition it and assign some drive letters and so on. Then I'll create basically an automatically booting file, autolaunch.bat in my case. And what happens is I will call disk part, reference this file. So the very first thing that happens is we run through disk part and apply that file. Then I'm going to create or use netuse to create a link to my share that contains my imaging WIM, right? So Z drive, now got to know the drive letter that I'll be using. So I'm going to map Z to this location. Then I'm going to, from the X drive, which is now Windows PE running in memory, I'm going to launch ImageX to apply the WIM that is stored up here. So that's going to take the WIM and drop it down to the C drive, right? And then once I get that done, I'm going to, I already have drive letter W assigned now to the disk. I shouldn't call it C drive, I should call it the W drive, right? And I'm going to use BCD boot to go ahead and apply the boot files to my W drive, and that way, once the image deployment is done and the system reboots, it will have the files that it needs to boot up, this time no longer PE, but the default OS that I created. Right? So hopefully that makes sense. A lot of moving parts here. If not, you'll see it in a minute. And so this, that is just testing it, getting it ready locally. Once we know that we have a process that works, now we have to translate it into Azure. And so you'll see that all I'm really doing here is I'm modifying the autolaunch.bat to now, instead of mapping locally a drive, I'm going to map that same drive, but this time from my Azure storage group, right? And then there's a couple of different things I have to do in my Azure storage group to be able to make that work. And then same thing, just apply it with ImageX and apply the boot partitions, and we'll boot into the newly applied OS. So there's a couple of other pieces that need to happen. So obviously we need to be able to get the WIM that we're using to image onto the VHD into Azure. So we'll also need to get the VHD that we've loaded with PE up into Azure. So there's a couple of PowerShell scripts that we'll use for the process next. This one that you see, which you'll, well, you won't see me demonstrate this because it takes not a short amount of time for a couple of the different steps. But you'll be able to see the PowerShell script here. Well, first, we're going to log in to the Azure environment, find our subscription, then basically load up the VHD into our environment. So that's going to copy it up. Then we're going to create an image out of that VHD, right? Then the next part of it, we'll need to go and create and attach a VM in Azure. Very, very critical. Even though you have, let me back up. So very, very critical. Even though you would see in the Azure console the ability to upload VHDs, in my experience and the experience working with John Saville and a couple of others, when you do that, it somehow messes the VHD up so it doesn't boot right. So using PowerShell is absolutely critical for uploading your VHDs and creating your VMs and so on, right? So the PowerShell for VMs really is convenient too, because you just need to add a few different pieces that PowerShell does really quickly for you. So the PowerShell script will load up the VM, add the NIC, create association with the VHDs, and on we go, right? Okay, so that's Windows PE in Azure. Well, we'll see that in a minute, right? So what about ConfigMgr OSD in Azure? So shifting gears here for a minute, we're going to use the pre-staged media approach, but we're going to do it in a bit of an inventive way, right? So first, we're going to start, well, before we even get into the flowchart, there's a couple of things that the pre-staged media approach will require. So pre-staged media requires that you specify a WIM file that it can read and know that that's the image that's going to be applied during the pre-stage staging process. Essentially, pre-stage is going to get the hard drive ready so that certain content is already available. You don't have to take the time of downloading that content on the network, et cetera, et cetera. So the pre-stage wizard will ask you for a WIM file. Well, in the case of what we're trying to do, we don't want to apply the WIM file. Now, you may, right? Pre-stage works great in an Azure environment too. If you want to use the traditional pre-stage approach, that's great. So you may want to take a full WIM and apply it to the disk, right? In my case, I don't, because what I'm trying to do is kind of get the equivalent of boot media. So in order to pass the wizard, I need to specify a WIM as a component. So back to that in a minute. Also, as part of the wizard, I need to specify a reference task sequence. So what the pre-stage wizard will do is look at that reference task sequence and figure out what all content is needed by that reference task sequence and make that available on the pre-stage process as well. Well, in my case, again, I'm not trying to do traditional pre-staged, I'm trying to do a boot image-like experience, and so I don't want any particular content in my task sequence. So what I'm going to do instead is use an empty task sequence, right? So let's start from the top. So I need to, in order to satisfy the needs of the wizard, I need to generate a WIM. but I want that to be an empty WIM, a blank WIM. So what I've done in my lab is I've just created a new virtual hard disk with nothing on it and attached it to a machine that I can then run ImageX to capture that empty hard disk, right? And it's tiny. It's, in my case, 2K, right, in terms of size. There's nothing on it. But that WIM will satisfy the needs of the pre-stage wizard. Also, I've created an empty task sequence, so you'll see that in a minute. So once I get that done, I'm going to work through the pre-stage wizard to create my pre-staged WIM. So the pre-staged wizard is kind of unique from the other wizards in that it doesn't create an ISO file or a USB stick kind of thing. It uniquely will create a WIM. That WIM will contain all that I need for the pre-stage process. So I'll then need to apply that WIM to the VHD. So I will import that WIM and then use standard imaging processes to apply the WIM to the VHD and my custom task sequence, which is basically empty. Once I'm done with that, I can stage my VHD to Azure. I can boot from my VHD and off we go. Now, one of the things, again, that's required here is that your process is completely automatic. Because, again, we don't have the ability to touch the machine while it's in a Windows PE-like mode. So everything you do will have to be automatic. But that's the general process, right? So we'll see that work in just a minute. So let's turn our attention to Azure templates. So I just want to walk you through the process a bit, just real quick. So let me pull Azure back in. So let's say that I want to go and create a new virtual machine. So I'm in my virtual machines node. I'm going to click add. And immediately I'm going to be presented with a number of different templates. I have my Windows templates, my Linux templates, and on we go. Just no end of templates that are customized to usually whatever needs you have. If you want a template running SQL, always on cluster, well, here it is. If you want a solution template for Cisco, well, here it is, and Citrix, and on we go, right? These are available to you. So pick whichever one you want, right, and need. And so in my case, I'll just choose Windows Server. Well, with this template and others as well, if I choose a virtual machine, whatever, Azure container, whatever, the options change. But in this case, I have a bunch of different flavors of Windows Server I can use. I'll just pick Data Center, and here I get my choice between using Resource Manager deployment or Classic deployment, and I'll use Resource Manager and hit Create. And then I just have to answer some questions. What types of disks do I care about? Username and password. What resource group I want. Create new or use existing. And again, resource group being that container that kind of holds things, up to you, right? And just answer some questions. And basically Azure will create the virtual machine that I've selected as a part of the process. And then after the virtual machine is created, I will need to go back in and customize if it needs additional configuration beyond what I've done, right? So really familiar process to build a virtual machine with Azure, right? And that's kind of how it works, okay? Now, let's get into the process where we are going to build Windows PE in Azure. Okay, so I'm going to take us part of the way through this. I'm not going to go all the way through because it just doesn't make sense from a timing perspective, but I want to show you enough to kind of get you a jump start. John Salvo's blog will detail all of what I'm going to show you and will be a good resource to use if you're trying to build PE manually to work in Azure. So to do this, I'm going to pull in my virtual machine, and because it already has some of the tools that I care about on it, let me get rid of that. Okay, so the first thing I'm going to do is launch my deployment and imaging tools environment. So that's there because I've launched it a few times. It's also available under Windows Kits. So I'm going to launch that, right? That is the environment that will load up a few shortcuts and map us out to the location we need for accessing certain tools. So the first thing I'm going to do is create my Windows PE image. So let me just copy, I'm just going to use copy and paste so you don't have to wait on me typing. So the first command is copy PE. So this is going to create my Windows PE instance that I'm going to leverage. So that's going to create it actually here, WinPE underscore AMD64. So here are the different files that make up Windows PE, right? And then I have a mount directory. So the mount directory right now is empty. I'm going to use it in order to mount Windows PE and create a few customizations, right? So let me go over here and paste this. So here's DISM to mount my image. The image file is going to be my boot WIM from inside my source directory. I'm going to mount it to the mount directory. So let me take care of that. Take just a second to actually get the files mounted. You can see that we're building into the mount folder right now, right? So creating what we need. All right, and once we get that done, I'm just going to customize it by adding one cab file. You can add whatever you need to, but just so you don't have to sit here and see me do every single one, I'll just add one cab file. So I'm just going to customize it. Shouldn't take very long. Then I'm also going to add in ImageX, right? ImageX, very, very critical for applying the images that we need to apply while we're in Windows PE. Just do a quick copy command when this is done. All right, so here's a copy command for ImageX, done. And then with those just few customizations, I'm going to unmount and commit the image. Before I do that though, you can see under my mount directory, I've added ImageX now, right? This wasn't here until I ran that command and so forth, right? So here we go. Let me complete and commit that process. So it'll take just a second to commit that back to the Windows PE source. So now that I have that done, the next step along the way is I need to transfer the PE that I've just created onto a VHD. That's going to make the VHD bootable into Windows PE, right? So almost done, and we'll create the VHD and transfer Windows PE onto it. All right, good. So now we're going to just go into disk part, and I'm going to use it. Now again, you could use Disk Manager and maybe another couple of ways to create your VHD. Disk part's really easy, so I'll just use it. All right, so let me again copy and paste a bit to save some typing time. So first thing I'm going to do is create, create my virtual disk. I also need a backslash here, otherwise it won't work. So I'll just call it, I think I have one already. I'll just call this A, so it's unique. All right, so I've created the disk, and then I'm going to attach it. All right, then I'm going to create partition primary. You are seeing me type here, sorry. All right, good enough. And then I'm going to give it a letter. All right, and format it. Good enough. So now you will see if I go into Explorer, well, first of all, I was given a format command, so I'm already formatting, so good. And you'll see that I have the V drive already attached. This is the VHD that I just created. It is writable now, just like any other disk, it's attached. So now what I need to do is transfer the contents of the Windows PE that I just created onto the VHD. That's pretty easy. So just do it this way. Right, and so what did I do? Well, I'm going to use copy and paste just to make sure. Oh, I know, I didn't finish the line. Here we go. Cool, so it's going to ask me, hey, you sure? Yes, and so great. We're formatting the V drive again, and then we're copying the files over. And so now if we go look at the V drive, you see I've moved a number of different files over. Here's ImageX. Well, ImageX will be in the root whenever I boot the drive, but this should now be a bootable VHD. So now I need to go ahead and go back to this part and deattach the drive. So let me select vdisk file equals, I think it was a VHD. Great. And then I'm going to detach it and exit. So now I have that VHD created. I don't have the V drive any longer, yet if I look at C, you'll see that I have this VHD. That is a fully bootable version of Windows PE, right? So now that I've kind of gone through that process, let me just take you over and show you what I mean. So I actually have a series of VHDs that I've created available for test and demo that I want to show you. Let me pop in this. So here's my WinPE disk. I'm going to just kind of work through a couple of the iterations of VHDs that I've created to show you the rest of this, because that way it won't take as much time. Go into settings. So I have no DVD attached, just call that out. And let me browse to my VHDs. So desktop. So I've got a couple here. This is my Windows PE VHD. The one I just created was letter A at the end. This one with the 1 at the end is just another exactly the same way that I created what you just saw. So I'm going to attach that one. Great. And I'm going to connect and boot this Windows PE. Right. Okay, so I'm going to start it. You'll see the activity take place here before you'll see it up here. So you'll see Windows PE is booting. You'll see it connect up here in just a minute. So this boot of Windows PE is just to prove that we can actually boot Windows PE successfully. And I have, so we're here, right? And I can shut this down and reboot it all day long, no problem. Turn off and turn back on, and it'll reboot exactly the same way, no problem, right? Because why? The files are on the VHD. The VHD is not being altered after boot, right? At least yet, right? So I can boot this as many times as I want, right? We are running completely from the X drive. So I do see my files on the C drive, but I'm running completely from the X drive. And so if I want to go into disk part and clean the disk, then I can absolutely go and do that. No problem at all, right? So I can select disk 0 and clean. And now if I exit this and go to the C drive, I have nothing. It's gone, right? So if I go and reboot this thing again, not going to work. And I'm going to do that to show you this point, right? So as long as I have just plain PE and I'm booting that and I'm not modifying it and I'm not expecting to image that VHD file or VHD with my new image I care about, then I'm good to go. But as soon as I clean that C drive, I'm done. This is not going to boot, right? Because there's nothing there. I've just wiped it out. So good enough. Now, let's go ahead and turn this off. And what I'm going to do now is basically shift over to a second iteration of this that I've kind of engineered. So now that I know that the VHD is built, it has PE in place, then what I need to do is modify this VHD so that it will automatically kick off and imaging will begin. Well, there's a couple of different ways that you can do that. You can go through disk part again and modify it and do it that way. You can use DISM to mount the PE piece again and modify it from there. I mean, there's a couple of different ways you can do it. Again, reference back to the blog article. Let me show you what mine looks like now. So if I go connect to my, not DVD drive, hard disk again, let me this time choose this one. So this one is ready for, it's been customized so it will automatically kick off and do imaging, but from my local environment. So let me just go ahead and mount that up and start it. So I have one shot at this to boot, right? Because it will automatically start up, clean the disk, and start to apply the image, as you'll see. So it's booting, right? And we'll be connected to it shortly. And I have a script here that it's going to kick off. It's kicking off WinPE. It's kicking up auto launch. I'm going to exit out of this, right? Because I don't want it to complete. But if I go to my C drive, it's still intact. We haven't gotten to the part of the diskpart script that will clean that, but ultimately we will, because on the root of the X drive now, I have a couple of files. I have this parts.txt, which will be my diskpart commands to go clean the C drive and get it ready, or drive 0 and get it ready. I have auto launch bat, which is my file that I immediately launch when PE boots. And let me start backwards. The way, or start from the beginning to the end. The way I get auto launch.bat to launch is under Windows System 32. I have, what is that file called? Startnet, that's right. So Notepad, oops, go away. So Notepad, Startnet. So I have a Startnet file. Typically it will only have WPE init, but I've also added to it to call auto launch.bat. So as soon as PE boots up, it will call auto launch.bat, and then auto launch.bat will include a command to launch diskpart and reference parts.txt, so it'll run through that first. Then I injected a pause in this just because I wanted to be able to stop this along the way. You won't want to do that in production. The next step is to create a drive mapping to this particular location where I have my image. This is just a local VHD that I can connect to. Specify the user name, and then also off to the right, which you don't see, is the password that I will use. So yeah, you will need to store a password in this file, which isn't the best, but shouldn't be a terrible thing, because in Azure, you won't be able to even touch this system while it's in this mode, right? Then once I've mapped the drive, I'm going to apply the image with ImageX, and then apply boot files, and then I'm done. Right? So this is fully customized to be fully automatic and just pick up and run after we launch, right? Okay, so that works, kind of proven out from the usage here locally. So now that I know that it works, the next step would be to modify this existing VHD, but tweak it so that it will work from Azure. So let me show you a VHD that I did for that. So here's my hard drives again. Let's browse to it and go down to, this time, the Azure iteration of it. Hit OK. And we'll boot this up. So waiting for it to connect. You can see that it is booting down here and will be connected shortly. And essentially the structure of what I have is exactly the same. It's just tweaked a bit for Azure. So let me show you what I mean. So I'm going to go ahead and Control-C out of this, and we'll look at the root of X drive again. Same file structure. The main difference, the only difference, is in auto launch, right? So all I've done here is, instead of mapping a local drive, now I'm mapping to my storage account. And then you have to also provide a username. Interestingly, let me maximize this time. The username is the name of the particular storage account. So you see the storage account name here and also here, right? And then in order to get access, I need to pass credentials that will allow me access. In this case, it's the contents of a key file, and that you can get from Azure. In fact, I will show you. If you go into Azure and go into, let me just go into my resource group, go into, this one's fine, any of them are fine. Go into my storage account, and then access keys here, then I can actually copy and paste my access key, and that's what I'm using in order to get access to that environment, right? So that's all good to go. We are ready to, we know that it's ready to go, and we're ready to upload into Azure. So the next step along the way would be to use the PowerShell scripts that I've showed you to get it done. So there's a couple. there's the VHD upload PowerShell script. And, kind of like I showed you on the PowerPoint, just need to adjust this for your names and locations and so on, resource groups and so forth. But this PowerShell script will actually upload your VHD and also create the image files that you need. Now, one thing that's interesting that I found along the way of using this, whenever you go to upload your VHD, we do require that you have access to port 445 so you can transmit the things that you need. If you don't have access to port 445, you'll just run into error after error after error. Well, I didn't think that I would have any problems because I'm running through my ISP. In my case, it's Charter Internet Services. But I could not get connected. And I finally did some testing and realized, yeah, in fact, Charter somehow is blocking port 445. So instead of using Charter, I just went with my phone, which happens to be using AT&T, and I tethered my phone and connected that way. And sure enough, with AT&T, they're not blocking port 445, so I'm able to connect through there, no problem, and was able to upload. So if you run into that, just know that 445 has to be open in order for it to work. And if it's not in your internet environment, maybe try another internet provider, maybe tethering your phone or whatever, right? But that works. And then it uploads the VHD, and then creates the image. And then once that's done, we'll use this script to go and actually create the VM, the components of the VM, attach it, and so on. So again, that might take a little bit, but at the end, you get your virtual machines running no problem, right? And so now we have the virtual machine running in Azure. Well, how do I know that it's running in Azure? Pretty easy. I can go over to my virtual machines and I'll show you, I can't interact with it, but I'll show you the PE that the one I just showed you running locally is running in Azure. It's sitting in a place that it will never go forward because I can't trigger it to go forward. And it's got the pauses in place, so it won't finish up until I remove the pauses anyway. So if I go down to boot diagnostics here, I will see Windows PE is in fact up and running. You see that it was executing through the auto launch, and because I have these pause commands, it stopped. If I didn't have the pause commands, it would just run on through the auto launch.bat, apply the image, reboot, and I would then have a running version of Windows on my VHD, right? But you do see it here. So again, the boot diagnostics piece, that is enabled by the script that I'm using to upload my VHD. Very important to be able to see what's going on with my disk. I can't interact with it, can't touch it, etc. But it's here, right? Okay, so let's pull that back out. So that's kind of building your VHD with just Windows PE in Azure manually and so on. Let's shift over to OS. So I talked you through the process of using or creating pre-stage media. Let me go through it a little bit more and show you in my environment. So let's start with the blank WIM and talk through that again. So specifically, pre-stage requires, as a part of the wizard, that you point to a WIM that you're going to deploy. In the way that I'm using pre-stage media here, I don't want to deploy a WIM that increases the size of the disk. I'm trying to simulate boot media. So I just need an empty WIM. So what I did is I used ImageX to capture the image of a blank disk. So if I go back to my ConfigMgr environment and look on my C drive, you'll see that I have a file called blank.vhd. So that's just a disk that I created completely empty, and then I captured an image of that blank disk and stored it away in ConfigMgr. So if I go to my package source and look at images, here's my blank image, and you can see that it is very small, 2K, right? So then I imported that image into ConfigMgr. Here it is, and I've distributed it to distribution points. So good to go, right? no size at all, but it's now in ConfigMgr, so I can use it as a part of the pre-staged wizard. Part two, or next part of this, is I need a task sequence. The pre-staged wizard requires a reference task sequence, and will basically look at that task sequence, scrape all of the content out of it for potential inclusion in the pre-staging process. For our purposes of using the pre-staged tool to simulate boot media, again, I don't want any additional content, just PE. And so I need to present a task sequence to the pre-staged media wizard, but I don't want it to have any content, right? So what I've done is created a task sequence called blank. If I go look at it, there is nothing in it, right? Now, one other thing I have to do is I do have to associate a boot whim. The reason I have to associate a boot whim is because that's required to kind of categorize this task sequence as an imaging task sequence, which only imaging task sequences will show up in the pre-stage wizard. So I've got that done and so forth. So we're good to go. Now, in terms of creating the pre-staged media, let me show you that. So if I go into the wizard now and create task sequence media, there is the option for pre-staged. And so I'll click next, and I'll just answer partially through the wizard. And now I'm going to create a file. Usually, well, for the other wizards, you would create maybe a .iso, right? But notice, in this case, you don't even have the option to create USB media. So for things like the boot media or the standalone media, you have the option of using a media file or USB. Here you don't have the choice of USB. Why? Because you're not creating an ISO, you're creating a WIM. Right? So I'll go through that process. It will ask me some of the standard questions, right? And then it will ask me, okay, where's your task sequence? So I'm going to browse to my blank task sequence. And then I'll click next. It's going to say, okay, tell me the rest of this. Great. Answer some of the questions. Great. And then we'll move on. And then it will ask me, okay, show me your image that you want to include. So I'm going to use the blank image and tell it where my distribution point are. Great. Fine. And move forward. It'll ask me a few extra questions, things that I might want to include. I don't want to include anything else, so I'm going to end the wizard at this point. But then it would go build my pre-staged, in this case, WIM. So that pre-staged WIM will have everything it needs in it to become to become bootable. Once I apply it to the VHD, I can then boot from the VHD and have my now ConfigMgr custom environment that I need, and I can apply whatever I want, right? So let's go do that. So I've got my pre-staged WIM created. I've already imported it into my image library. So let's look at that, package source, images. So here's my pre-staged WIM. It is a bit bigger than a standard boot media WIM, but that's just kind of the nature of the beast. So I would import this into ConfigMgr as well. And it is imported here. So now I just need to have a task sequence that will go through and apply that pre-staged WIM, right? And so that's this task sequence. So I'll go edit it. And it has 3 steps. It's going to format and partition the disk. It's going to then apply the data image. This is not a true image. It's not an OS image. We're just trying to write the contents of the WIM file to the local drive. And then once the contents of that WIM file are written to the local drive, I'm going to shut down PE. Just turn it off. Right? Be done with it. Right? That way, the next time I boot into that environment, I'm running Windows PE, but this time customized for ConfigMgr using the pre-staged media. Now, let me show you that I have that working. So let's pull this back out. I will pull in my local environment again. Here's my Windows PE running my pre-staged media. So let's go connect to it through settings. And we'll see that it is running my pre-staged to boot VHD. and no DVD drive. So let's go ahead and turn it on and see what we get. So I will connect to it, start it. We'll see it booting down below again first as we go through. And so it's booting. You can see it kicking right along, no problem. Here it launches into PE, and we'll have connectivity up here shortly. All right, so there, we're loading our task sequence environment, good to go. And again, it's just going to park here at the screen because I haven't added the customization that I would need in order to automate the process. What customization would I need in order to automate the process? Well, here you would use things like required deployment, so that whenever this loads up, it will just kick on and go forward right away because there's a required deployment that it sees. You would also be able to use task sequence variables to kind of complete the loop, perhaps, and get it to go forward. And you could even, this is, after all, Windows PE, so you could actually add some commands in there maybe to make it work. But you can see if I go forward, it's going to act just like boot media, searching for policy for my computer. I won't have any, right? But essentially that's what I've got going on. All right, so I'm going to turn that off. So using the same scripts, I can stage this into Azure, and I have. And so whenever I go into Azure now and look at my virtual machines, you will see one of them now for pre-stage to boot. If I go into the same section of boot diagnostics, then you'll see that it's sitting here at the screen waiting for input, which it will never get because I don't have any ability to interact with it, but at least I can see it, right? All right, so let's pull this back out. Okay, so that really does, kind of wrap up what I wanted to talk to you about the imaging. A few tips and tricks as we start to wind down. So, said it a couple of times, say it again. Test and develop on your local VMs first. Absolutely critical to make sure things are working the way you want them to work. When you're testing, make sure you're using VHDs, not VHDXs. Azure does not support the VHDX format. When you're working especially whenever you're working with the Windows 80K pieces, make sure you're using the deployment and imaging tools command prompt. Also, if you're interacting with your storage accounts, Storage Explorer is a really nice way. Yeah, you can absolutely map a drive to it so that you can use just Explorer to look at it. But not all things can you map a drive to. Storage Explorer allows you to work with all of your storage accounts. So I'm just launching Storage Explorer for you. Free download. So if you launch it here locally, it will go and basically enumerate all of your storage accounts and let you see what's there, interact with things, whatever. So I'm enumerating all of my storage accounts. So I can go in here, see what I have. So let's see, blob storage. And I have some different files here. I can right click, create a new container. I could upload and download from here. And really nice little tool if you're doing a lot of work with storage accounts. Use PowerShell for your VM upload to Azure. Very, very important. Don't know VM and VHD. Don't know what happens along the way if you use the UI to upload the VHD, but something happens odd and the VHD doesn't actually work well, at least in my experience, and those of a couple of others. Port 445 has to be open. There's also a little tool that I'll just mention here. It's interesting, may work for you in certain scenarios. There is a tool, which is essentially a PowerShell script that you can download from the TechNet gallery at the link that I show, that will allow you to take an ISO and convert it to VHD. That might be interesting in certain scenarios for you to be able to upload a VHD created from an ISO and manipulate it from there. Just mention it there in case it is. And with that, we're done, right? Hopefully this has at least been interesting to you to see that things like this can be done and maybe stimulated some thought. So we will end it here and we will see you next time.